In this video, I'm going to show you how to solve a logarithmic equation. So the first few examples are going to be logarithmic equations where there's just one log, and so we don't need to use any of the condensing logarithms properties. But it's important to know how to change form. So if we're solving a logarithmic equation and we have our x is on the side with the log, like these examples have them, then we need to change it to exponential form. And some people have different tricks for this. One trick is called the BAE trick, the base, then you go to the exponent, and then it's the answer. So it's like a swoosh pattern, base to exponent to answer. And so in log form, it spells BAE, B-A-E, but when you go back to exponential, you do the base raised to the exponent is equal to the answer. So it's kind of like a mixture between the BAE trick and the swoosh trick. So if I'm here, and I'm going to start with my base is 4, then my exponent's 3, and it's equal to the answer, which is x. So the base raised to the exponent is equal to the answer. And now I can just evaluate 4 to the third, which is 64. All right, for number 2, my base is 3, my exponent's -2, it's equal to x. So again, I just did this base to exponent to answer. And 3 to the -2 is 1/9. All right, for number 3, there is no subscript. That means the base is 10. When we don't see a subscript, the base is actually 10. So my base is 10, my exponent's 2, because logs are always equal to exponents. Again, BAE, base, answer, exponent. And so then my answer is x plus 1. So again, this is also, some people refer to it as the swoosh, or I think some people might even call this like the loop and swoosh, or swoosh and loop. I just call it the swoosh method. So 10 squared is 100. And then I'm going to take 1 away, and I get 99. All right, number 4. I have a base of 5. My exponent's 2. It's going to be equal to 2x minus 1. And so again, this is the swoosh here. Base, exponent, answer. 5 squared is 25. Add 1. Divide by 2. And x will be 13. All right, now sometimes the log is not just in one place like that, and so we have to use some properties to condense our logarithms, and those properties look something like this. So you have to have the same base. That's why I used b. You can use any variables. If you look these up, you might see it written a different way. But if they're separated with addition, we multiply. And then if we have 2 logs, same base, separated with subtraction, this is rewritten as division. And you just go in the order of the subtraction. So m came first, so it's the numerator, and n is the denominator. And then if we have a number multiplying out front, we rewrite this as an exponent. All right, so let's practice these properties. So the first problem is separated by an addition sign. So I'm going to rewrite it as 1 log base 2 of x times 8. So I'm multiplying the x times the 8, which would be 8x is equal to 6. And now we can solve the same way we did the first 4. So 2 to the 6 is equal to 8x. And 2 to the 6. Our brain's not operating that fast this morning. 64. Divide by 8. And I get x is 8. All right, number 6. Another addition problem. So I'm going to skip that one. I'm going to go to number 7. I have log base 3 of x over 6 is how we rewrite it when it's separated by subtraction. And then I'm going to swoosh base to the exponent to the answer. 3 to the third is equal to x over 6. 3 to the third is 27. Multiply by 6 on both sides. And 6 times 27 is 162. Now you can check any of these problems in the calculator pretty easily. You just plug back in your x value. So I have log base 3. Remember, we go functions in Desmos. You find the log with the little number. X, was x on top? Yes, so x minus log base again. I think it was a 6. And it gave me 3, and it was supposed to give me 3, so I got it right. All right, the last example here that we have not looked at is when there is a number in the front, and I don't see one of those, so I am going to make one up. And so let's say that this problem had a 2 in the front. We're going to change it. And so if there's a number in the front, then this would first become log 5 squared. It comes up to the top, plus log of x equals 2. And so then to combine these, we use multiplication. So we're going to have the log of 5 squared times x. 5 squared is 25. So that would be 25x is equal to 2. And then when there isn't a base, remember that the base is actually 10. And so I'm going to swoosh it. 10 squared is 25x. And 10 squared is really 100. And if I divide both sides by 25, I get 4. So again, I'm using these 3 properties to get them to be one log. So if it's adding, rewrite it as multiplication. If it's subtracting 2 separate logs, rewrite it as one log with division. And if there is a number out front, you raise it to be the exponent.